All right, so section 610 is graphing radical functions in standard form. So we've done like solving of radical functions. We've rewritten radical functions into exponential functions. We've done a lot of stuff with radicals. What we haven't done is graph them, okay? So in the very beginning right here, I know this has been up for a little while. I put right here a recall. I said, do you remember how we graphed absolute value functions, right? They look like letter V's. And the formula y equals to a, absolute value of x minus h plus k. We know hk is our vertex and a is our amplitude, right? A tells you if it's positive, it opens up. If it's negative, it opens down, right? And also remember, a is kind of like our slope for this function. It can kind of tell us where our next points are located. And then we did quadratic functions. And with quadratic functions, notice how the function is almost identical, just that instead of absolute value lines, we have a parenthesis square. But hk is still considered my vertex. A is still kind of considered my slope. And if a is positive, it opens up. If a is negative, it opens down. Okay? Why do I show you this? Well, because radical functions are pretty much the same formula. They just change the notation a little bit. So instead of absolute value symbols or parentheses squared symbols, we're using the radical in it instead. Okay? And notice the h and k, well, hk is no longer our vertex. It's actually our origin. Okay, so I'm going to kind of put that right here. hk is the origin of the graph. Okay, so this is the origin of the graph, where the graph starts. Okay, and then where it starts, it only shoots off in one direction. If a is positive, it kind of goes upwards and curls. If a is negative, it goes downward and curls. Okay, so and remember, hk is just going to be our origin. All right. And notice how in the little pictures, I put the HK where the dot is, right? So HK is down here for the first one where A is positive. And then HK is towards the top when A is negative. All right, but graphing this stuff is pretty easy, but here are the couple of steps you're gonna wanna do. And a calculator could help you, but it doesn't have to be used, but it could help you. What you're gonna do is you're gonna graph HK, and then once you graph HK, you're going to pick a couple of extra points to try to graph. Okay? So let me show you how this works. This is pretty simple. I know you might say like, oh man, graphing, I don't like it. But I always try to show you guys the easiest way to graph these things. So let me show you the easiest way to graph these types of radicals. So this one's the most basic radical function. Okay? So y is equal to radical x. So based on this equation, bless you, what is my a term? It's 1, right? So a is 1, which means it's positive, which means the graph is going to look like this, okay? It's going to look something like that. What's my hk? I mean, do you see h and k? No, so that means it's 0, 0. So here we go. Graph your hk. That's right here, 0, 0. It's right here. And now I got to figure out, I know the graph is going to go like this, okay? I know it's going to go like that, but I need a little bit more direction. So I'm going to make a table. Now, whatever I plug in for x, I'm going to have to take the square root of it, right? Because it's the square root of x. So I'm only going to pick numbers that have square roots, okay? So let me pick a 1. What's the square root of 1? 1. All right, what other number has a square root? 4. And the square root of 4? 2. So there you go, just so I can make it easy. Now, do you have to pick those numbers? No, you could have picked 2 and then on your calculator figure out what square root of 2 is, which is 1.41. But if you don't want to get decimals, pick numbers, kind of try to be smart about which numbers you're picking. Okay, so here we go, 1, 1. And then 4, 2. And there's my graph. Okay, and that's it. I mean, does that seem too bad? Not terrible, right? So here we go. Example number 2. So y is equal to 2 square root of x minus 1. So y equals to 2 square root of x minus 1. So just like I did last time, I want to figure out my a term. So what's my a term? It's 2, which means it's positive, which means the graph will look something like that. Okay, what's my hk? 0, negative 1. All right, 0, negative 1. So I'm going to go to 0, negative 1. I'm going to put a dot right there. Now, I'm going to make a table, x, y. Now, according to my equation, it's square root of x, right? So in other words, whatever number I pick for x, I'm going to have to take the square root of it, okay? So I'm going to pick easy numbers. So I'm going to do the same ones I picked in the previous one, 1 and 4. I could also pick 9. I could pick 16, but you really don't want to make 16 tick marks on the x-axis, right? So that's what I'm going to pick, 1 and 4. Now, the square root of 1, well, when I plug it in, let me kind of show you guys here. I'm going to put in a 1 into the square root. So it's 2 square root of 1 minus 1. Now, the square root of 1, that's 1. So this is 2 times 1 minus 1. Well, 2 times 1 is 2, and 2 minus 1 is 1. So this came out to 1, 1. Okay, so I'm going to put that right there. Now, let me plug in the 4 into the equation. 2 times square root of 4 minus 1. The square root of 4 is 2 minus 1. 2 times 2 is 4 minus 1. So that answer is 3. So at 4, I have to go up to 3. Whoops, I forgot to put it on the chart right there. So let me go ahead and draw this, and I'm done. Okay? And that's it. You're going to plug it into the formula, work it out. Whatever answer you get, that's going to be your y value. Okay? We are going to do one that's upside down, but right now let's do one more that's a normal looking one. Are we okay with this one, by the way? The hardest part is always going to be like this part, I think, the calculations. Okay, make sure you're calculating it right, or else your answers are going to, or your graph's going to come out looking kind of weird. Okay, it should never be straight lines. This is a curve, no straight lines. Okay, this is not linear. This is a radical function. Now, if you're given a problem like this, you might want to rewrite it just to make it look more normal. In other words, y equal to the square root of x minus 3 minus a 2. Well, the positive is still there. It's in front of the square root of x minus 3, right? I just don't have to write it because, I mean, I could. It just looks kind of weird, right? So I don't put it on there. And the minus 2 sticks, or the negative sticks to the 2. So wherever I put the 2, I'm going to put it negative. All right, what's my a term? It's a 1. That means it's positive, which means the graph looks normal, right? It's going upwards. What's my hk? It's 3, negative 2. Yeah, don't forget about h. It lies to you, right? 3, negative 2. So 3, negative 2. It's right here. Excuse me. So I'm going to have to pick some numbers, okay, that I'm going to put in for x so I can calculate. So what number can I plug in for x that when I subtract 3, it becomes like an easy number, like a 1? So what number should I put in for x so that when I subtract 3, it becomes a 1? 4. I'm going to try x equal to 4. So square root of 4 minus 3 minus 2. What's square root of 1 minus 2, which is negative 1. So 4, negative 1. Okay. What number can I use for x? So I use the number 4 because 4 minus 3 equals 1, and I know the square root of 1. The other square root I know is 4. So what number can I plug in for x so when I subtract 3, it becomes a 4? A 7. Now you might say, I don't have 7. Well, it's okay. We'll just kind of expand a bit. If I plug in a 7, this is what I get. 7 minus 3 minus 2. That's square root of 4 minus 2. And the square root of 4 is 2. 2 minus 2 is 0. So at 7, my point is at 0. Okay, so let me see. 1, 2, 3, 4, 5, 6. So at 7, it's at 0. It's right there. So there's my graph. Now, if you're wondering, well, that was kind of hard, like to think of a number that when I subtract 3, I get a 1, and then I had to think of a number, so when I subtract 3, I get a 4. If you don't want to do that, that's okay. That's okay. Just use any number, and you're just going to have to use your calculator, and you'll get decimals. So I tried 4, right? I could have tried 5. The square root of 5 minus 3 is 2. Radical 2 is 1.41. 1.41 minus 1 is negative 0.6. So I could have done that. Okay, there's nothing wrong with picking any other numbers. I'm just trying to pick the numbers that are easiest for me to do in my head. Okay, but you don't have to. You pick whatever numbers you want. Notice I'm picking numbers to the right of the graph. Okay, to the right of my HK. So HK was at 3, negative 2. So I picked a 4, I pick a 5, a 6, a 7, and 8, those numbers. Okay, because if I pick numbers to the left of that point, the numbers inside of my square root will be negative, and I can't do square root of negative numbers, right? So only certain numbers work, okay? So I always pick to the right side of it, okay? So here's the last one for us. So we got y equal to negative 5 square root of x minus 2 plus 4. Remember, we know square roots. Do we know the square root of 0? What's the square root of 0? 0. So you can also try to figure out what numbers make it 0, right? 0, 1, 4, 9, 16, those numbers we know square roots to, right? All right, what's my a term here? Negative 5, which means that it's negative. That means the graph is upside down, okay? It still goes to the right, though, okay? It's just upside down. What's my HK? 2, 4, all right, 2, 4. So I'm going to go to 2, 4. I'm going to put a dot right there. Now I got to figure out a couple of points, okay? So here we go, x, y. All right, one of my points. Well, since I'm my x value of 2, let me try 3. Let me try 3 right next to it. If I try x equal to 3, I get negative 5 square root of 3 minus 2 plus 4. That's negative 5 square root of 1 plus 4. Well, the square root of 1 is 1, and 1 times negative 5 is negative 5. So negative 5 plus 4, that's negative 1. So at 3, it's negative 1. All right, let's try a different number here. What other number should I try? I tried a 3, which resulted in a 1. 6 minus 2. Yeah, we'll try 6. I like 6. Because 6 minus 2 is 4. The square root of 4 is 2, right? So good. So negative 5 square root of 6 minus 2 plus 4. That's negative 5 square root of 4 plus 4. All right, the square root of 4 is 2. 2 times negative 5, negative 10. Now add 4, negative 6. So 3, 4, 5, 6, -6 right here. So my graph is going to be really elongated, but it's still a curve. It looks like that. Notice when the number in front of the radical becomes a big number, how it stretches it, right? It really stretches it. When it's like a 1, it looks pretty normal. But when it's a 5, it kind of starts to grow really quick, 5 times as fast, okay? That's why they call it the amplitude, because it's amplifying the values by 5, okay? Whereas if I were to put a fraction of half or a third, it would make the graph real small, because it's cutting it down into smaller numbers. So this is what your homework is like today, guys. It's just graphing these functions, and you are going to have to do some mathematical work. So again, if you want calculators, I didn't bring them out because I didn't think you'd want to use them, but maybe you might for stuff like the table. You might want to punch it in. But I'll bring the rest of them out for you guys. But it's not terribly difficult stuff. I think the hardest part is picking your x values. But if you're going to be using a calculator, you can literally pick anything, because the calculator should give you answers in decimal form. Okay. Remember, just press that SD button, the one that makes it look like instead of square root of 2, you want to say 1.41. Just press that button. That should give you your decimal value. That way you can graph it properly. So let me go ahead and stop this, give you guys your homework.